So let's start. So a little bit about me. I'm Irina Kamalova. I'm software backend engineer in Revolut and director of this friendly community, Women Who Code London. And sometimes I give talks online, which I think good fact about me. First of all, I will give you a brief introduction about what we're going to cover today. So this will be 4 interesting behavioral patterns. It's state, strategy, chain of responsibility, and iterator. So let's look at them. First of all, state. So I would like to start with introduction of the object. The object, this is called session. So suppose that you have application and you have to connect to another application, or user connected to your application, and you have session in this application and you want to track these sessions. You should say that, you know, this session have time to live and last updated time, like the last time it was updated. And when we create this session, we say that we created it for several seconds or for several minutes or for several hours, which will be time to live. And we say that, okay, last updated time is right now. System current time means it's current time. It's basically current time. Please let me know if you need to check with some Java syntax. I will explain. So now let's suppose that we have a program which has to collect stale session, which means that session already expired and nobody wants to use it anymore. So we say that this is some property of session. It means that session is stale. So we create this isStale session method, which means basically that current time minus session last updated time more than session time to live. If you see, it's on the bottom. And we want to collect all these stale sessions, and we will clean them. So looks good and looks simple and looks clean. Now, we need to cover it by tests. So how tests will look like? What we can do here? Okay, someone please mute yourself. Okay, I need to check. So probably I stop sharing because I need to check who hasn't been unmuted. Okay, I see several people who I need to mute. Sorry for this. And now I can check. Okay, so I think it should be fine. Please let me know again if you will have any questions. And I continue to share. Actually, let me try to share this window. Okay, I can still have microphone. And yeah, let's continue. Yeah, and we are here. So how are we going to test our application? We should create at least 3 tests, because first of all, we need to check that everything can work without any errors. So we create our object, style session collector, with any mocked repository. For example, array list can be repository. We just put them in the list. And with some cleaner service, we mock them. This is called mock, and it's used by Mockita in Java. It's a powerful instrument to test everything you like by just mocking objects by just pretending that this object exists. And you also can say what exactly is the behavior of the object. So the first test, it's like we don't have to throw any exceptions. Everything should work when we do style session collector, when we do execute method. Also, with this reference, I hope you know a bit about Java 8 syntax. But again, if you don't know, if you don't understand what's written here, please let me know. So here we just execute style session collector. And we also verify that our mock cleaner actually cleaned session. That's how we can check that our function come into method and did this method. So again, if you looked at the code, we see that execute basically if there's style session, we just clean this session. Okay, we also created a session with time to live in 1 millisecond. That's why we can show when we come into this test, it's already expired. It's already stale. Yeah, because we do this method here in this private boolean is stale method. Okay, so we looked at the first test. We just checked that everything is worse. Then we look at the second test. Now we have to say, you know, there will be session with very long time to live. So when we will try to collect this session, it won't be collected. So at the second test, we just verify that there was no iteration with the object cleaner. And yeah, that's it. We check that there are no errors, no exceptions. So ICR doesn't not throw, and verify there are no more interaction with our mocked object. And at the third test, we check that if our object do throw exception, when we need to check that our method throw exception. Anything that need to be clarified in this test, please ask me. It's not about object-oriented patterns. It's more about syntax in Java and how to write tests on the function. I'm waiting for a bit for a question. I also can check chat, but it will be on the same window. And I also need to check if anyone unmuted. Okay, I see one person is unmuted. I also have a property, mute participants on entry. Yes, so I hope I wouldn't have problems with background noise. And okay, I don't see any questions so far. So I continue this presentation. Yeah, you see it. Okay. Okay, so method was pretty clear. We just check that session should be collected if it's stale, and stale in the same class. Now, how do not test session behavior? The problem here is that actually why I should test two methods. I won't only test one method, execute, but I need to care about what's happening with stale session. So I need to provide exactly stale sessions. What can I do to avoid testing this session behavior? And what is your thoughts? Any ideas? So how we can somehow do not use this method here in this style session collector class. Okay, so here state pattern is becoming, and state is a behavioral design pattern that lets an object alter its behavior when its internal state changes. So actually, honestly, I won't just have some property that session is stale instead of putting this method into style collector class, because it's collector and I don't want to put their logic about how state is, how session behavior is implemented. Actually, the thing that state is stale when this condition that current time is more than difference between last update time and time to leave. So I just put it in session class for now. And that's already like the first step to state pattern, where I say, you know, session have its own state. And if its own state is stale, I can check it directly from state and directly from session. And in this case, I just drop this method. And I already have this session object as a parameter. So I just get this session object from repository. And if it's stale, I clean it. And that's it. My service becoming lighter. And now I have, first of all, test the session object. Now I say, you know, I can have just sessions that I created some 1 milliseconds ago, and right now it's 2 milliseconds, and it's already stale. So yeah, this is basically assert true, and this will be assert false. Now my test for service becoming a bit lighter because I can mock session object as well. Now I can say that if I ask session, is it stale? Then I return true. And in this case, my cleaner should clean this session. That's it. And if I say that my session on the question if it is stale, returning false, it's not stale. I verify that there were no cleaning. Yeah, and the third one is just the same. So it's like the first step to understand why it could be interesting to check session state with state pattern. And let's think that session actually more complex object. And it's also have several states. Session can be created, session can be activated, session can be terminated. Session, if, for example, now I can say, if session is stale, session coming in the state of terminated. And the cleaner could also terminate session and then clean it from repository to mark it terminated, for example, and save. So you see, we can create several methods depending on the state. And every time you just check if session is created or if session is activated or if session is terminated. And you just check this, you just check this. And it's very powerful, like you don't need actually to know what internal things. Sorry for the background noise. You don't need to check internal things. So if we would go to Golf Patterns official website, we will see adorable diagram there, which show how to implement this pattern state. So they say that basically state is class, and you have several implementations. And you can have also handle as a method. In our example, I'm using enums in Java, so they allow me to create several implementations of the state of the session. So state basically enum, and implementation is created, activated, terminated. And if I will draw the same diagram that Gang for draw, I will say that, okay, my state, I have in session, I have state. This state have three states. Basically, it's created, activated, created, activated, terminated. I also could use active instead of activated. And yeah, it makes sense to use active as well. And I can ask session, are you active? Are you stale? Are you terminated? Are you created? And session have just methods. Is active, is stale, is terminated, is created. Maybe I don't need is created because this is like the first state of the session. So here is, you can be flexible. But the most idea of this state that you say object has some state. Yeah, and here I put more links for resources. And this state, basically, it's applying in software design everywhere. Suppose you have vending machine with snacks, and you can say that your vending machine state is vending deposit state and vending stock state. So in vending deposit state, you put money there, and in stock state, you're just waiting for someone put money there, and you gave crisps, for example. I also added the source, so after this presentation, you can check this example as well. TCP connections, TCP sessions. So it also has several states, and it's very easy to describe these states with state pattern. So if you would like on actually states of TCP connection, it's different states for client and server. Some of them are the same, but you can say that you have all these states as implementation of TCP connection state. In Java, they all could be enum variables. It's very easy to use enums, but the idea, you use them as a state of your object, in this case, TCP connection state. This concept perfectly applying to finite state machine. Finite state machine is also like pattern to design software. And the idea is you have states. For example, you have this beautiful tourniquet where you can, you know that if you put the card, like in the modern world, we just put the card and it's unlocked, but it always locked. It has basically two states. And in previous ages, we put coins there. That's why in the example on Wikipedia, you can find it and check, and they have coins. So you put coin, and this becoming in the state unlocked. And when you push this, and it's coming to the state locked again. So only two states. And why finite? Yeah, because we have finite number of states. So would you able to share examples that you think fits perfectly finite state machine? For example, elevator also fit because you have several states and this is finite number of states. Hello, any ideas? What else could be the state? Okay, we will left it as a small homework for research. Some properties of finite state machine. Finite number of states. Only one state per time, like your object can't exist in 2 states per time. Process to go from one state to another is called transition. So you can say, you know, my model in this state, then the transition is happening and my model becoming in this state. Transitions are strictly declared. So you can say that you go from this state to another state and only in this way. For example, you go from created to active and from active to terminated, but you can't go from created to terminated, or okay, that could be, but you can go from active to create. It's strictly declared. If you try to go to active, for example, from terminated, you can say now it's an error. So that's mean transitions. So ways from one state to another state, they're strictly declared. And finite machine has a termination state. But you can, for example, declare that even if my model terminated, it can be created again. So you can have transition from termination state to the first state. Okay, I hope everything is clear. Please let me know if you have any questions.
Can we see as something like payment as a state, behavioral state machine? Like, you know, the payment is started and at the end it will be paid. So money transaction. Is it something?
Yes. It's exactly the example. Transaction, money transaction, it can be, especially in our world where we have a lot of parties which participate in these transactions. So yes, it's applied to transaction perfectly. Transactions can be created, can be processed by Visa, by MasterCard, can be, can be also charged or paid and completed, for example. So yeah, that's exactly. Also, life of user in your system, it's also perfectly fit with finite state machine, like user authorizated, so it can be created but not go through authorization state or not prove their documents. So it's only created, then it's authorizated or checked past state, and then it's active state, and it also can left your system, decide to sign off from your service, and now you say it's in terminated state, or it can shut down your subscription and be shut down, or for example, it can be terminated, but also it can be deleted. So you can have like 10 different states for user in your system.
And also some other example would be access token, I guess, which started, it has a lifespan. And after that, some, depending on this similar to this session, for example, 1 hour or few hour,
yes.
It will.
Yeah. Yes, I totally agree. It's a good example. Thank you so much. Okay, so if we will look at TCP state, here is example of how state can be implemented. This is example on official Gov pattern site, so if you'd like, you can check as well. And TCP connection have TCP state, which is established, listen, and closed. Another good example, it's a site that's called Guru of Patterns, and they have very beautiful catalog of patterns as well. I really recommend it. They say about document. So document has also state, and draft is a state of document. So example is pretty simple, like only draft state. And it also applies to document in the system. Advantages of this pattern. First of all, single responsibility principle. You organized code beautiful. If you remember about our solid principles lecture, and as I promised, we repeat a bit here. So single responsibility. Now your class responsible, your object responsible for its state, and you don't need to make another class like collector for sessions to be responsible for their state. Open closed principle, so new states. It's very good to say that, this state, you also could say that there's stale state, and at some time you say that your model become stale. And in this case, the method to make your objects stale, for example, is closed, but actual information that now it's stale in the state, it's open, and it simplifies the code that in the context. For example, TCP connection now code really simplified because you put always logic about established, listen, or closed TCP state in state. Okay, and disadvantage apply only when you indeed have states. Do not overuse this pattern. Okay, any questions about state? And now let's go to strategy. I love this pattern. So the example here. Now, again, our stale session collector. We need to implement a job to collect stale sessions and clean them. So basically we have interface and job which execute something. And we have this session repository again, session cleaner service. And if session is stale, we clean them. Everything is perfect. Now, and as I promised, solid principles. So here we implement interface, but when we want to use this session collector job, we just say, I want to execute job and I don't care what is implementation. So with this interface segregation principle, we use here dependency inversion principle, which means that we could create this by new released and the new cleaner service just here in this stale session collector, but we, instead of doing it, we provided it to Constructor. So this is a very simple step to be a good person and follow dependency inversion principle. And we have only one method execute, which check method in session and get method from session cleaner service clean. So our service also have one method. I mean, we do not try to clean sessions here because here we already get them from repository and check them. And the logic to clean them we delegate it to another service, which allows our job to be single responsible only for this execution, only for this collection of stale session. And that's it. It's just stale session collector. It's not cleaner. So we delegated this. So it's single responsibility principle. Now we already seen how we can test it. Now, our clients wants to make this job being able to report about execution, which makes sense. And we decided to create a new method with reporting. So in case if we have reporter, we need to add reporter. We add their method execute with reporting. We do all this reporting and then do execute. We just reuse methods that we already have. And we add more parameters. Now we changed a bit our tests because we need to create style session collector with 3 parameters. Well, 2 previous methods to test, they pretty the same, it's good. And we add a new method to test our reporter. What if our reporter will fail? So we mock with behavior because we mocked basically reporter. We mock with behavior, and we say that when we try to report anything which Makita allows, Makita is powerful thing, we throw exception. So we check that if something will wrong with reporter, we will also have exception, which makes sense, which pretty simple, but because you want to test it, you would like to create more tests on it. And what went wrong? First of all, we had to rewrite the constructor, and we had to rewrite our tests a bit, but yet. And okay, we can survive with it. Now our client would like to make this job being able to delay in execution. So this is a job, but some application need job to be not at the start of application, but after some time, to be sure that all resources, for example, all resources initialized. Okay, we say, okay, now we have new parameter delay. We put it in constructor, we put a new method execute with delay. We say that, we can suspend our program, for example, by thread sleep delay. This is just for this thread sleep delay method because it's thread. We also need to catch interruption exception, and we just create new exception, but with some details of what's happening. And we just execute the method, or execute with reporting. So it's not really beautiful. It's not really flexible. And what is your thoughts? How we can make it better? Any ideas? And my solution here is execution strategy. So we say that execute method of job is the same, but we also have some strategy how to execute this job. And what we do next? We create job runner, which accept job and our strategy. So job runner accept job and strategy and just run our job with some execution strategy. And that's it. And original implementation of our job and interface haven't changed. Yeah, one more thing. When we edit all this in interface, well, in Java 8, we already have default method, which says we not support this object. with method. But before Java 8, we couldn't even do it. We had to provide with in interface. That means that if we create another job that will implement this interface job, this job should execute with reporting, even if it doesn't have to execute with reporting. So another class, another any job could create, execute with reporting and throw their exception like unsupported exception. I do not support this method. But yeah, Java 8 allows us to do it in interface, which means that we can make our interfaces more flexible. And but now we don't need even do it. We just remain the same job with the method execute, which is pretty simple, which can be even functional interface. That's very beautiful. And we say that now we have job runner. Again, job runner get this job, and that's it. And what can be the strategy? The strategy is reporting. So now our reporter go not in our previous style session collector class with this job. It's go to execution strategy. And now we say that execute job with reporter. We can do it by reporting, and then we execute job. Yeah, I hope it's clear. Let's look at delaying strategy, delaying execution. Now we say that, we want to delay our execution, and we put the parameter long delay. And we say that, okay, we will sleep before execute. And we even can combine these strategies. So we can create a new one, delaying with reporting execution, put there both reporter and delay. And now we say, first of all, we delay, then we report, and then we execute. So we can combine them by a new execution strategy. Okay, I hope it's clear. I hope it's it's clear what is strategy. It's super real life examples. So it's super real life examples. That's why they probably be more complicated. But I hope for, it will be super useful in your real life. If you would like an original diagram for any strategy pattern, it will look like this. So you have strategy and the context. And okay, the question for you, what is the context in our case when we implemented it? What is the context here? Strategy goes into context. So what is the context here?
The collector?
Sorry, pardon?
The sessions collector?
No, session collector just job.
I think so it's execution strategy is the context.
Yeah. No, strategy is strategy, but strategy part of context.
So job runner?
Yes, this is the answer. Yes, that's correct. Perfect. So in our case, job runner is our context, and execution strategy is strategies that can be implemented to be reporting, delaying, reporting delays, anything you'd like. I wanted to put it here because when you look at this diagram, you think, well, really, what is the context? And it's tricky to understand this pattern. But this pattern can simplify your life in an incredible way. Like you can start to apply everywhere strategy. It's really powerful, and it really makes your code base really flexible. So advantages, you can swap any algorithms. You can do strategy execution with reporting, without reporting, delaying, everything you like. You can isolate the implementation delayed, so we don't need to put reporter at original job because, well, job doesn't care about any reporter. Job just want to do their job, so you isolate them. Multiple device support, that means that, okay, that's, okay, it's about another example. So, for example, if you have devices as a pattern, as a strategy, you can use multiple devices. You can replace inheritance with composition. Yeah, what is it about? Composition, when execution strategy becoming part of your job runner, and yeah, that's you could also. Well, there was another way to do all these things. Who can provide some idea, like just here, when we wanted to extend our job, what else could we do? Any ideas? Like there could be another way.
I guess there's also decorators.
Yes, that's true. We haven't covered decorators in this track. We will cover in next session. And we touched it a bit in solid principles session. This is true. A decorator also a pattern that could allow to do it. And you could extend style session collector to style session collector with reporter. And then you could also extend it into style session collector delay with delaying, extend style session collector. Yeah, in this case, you just have execute method and you just can do not even override it, the same method. But you put another method, like you decorate style session collector, that's right. And if you apply a strategy pattern, why I wanted to do it, because I wanted to say the fourth statement on this slide, you can replace inheritance with a composition. Personally, I don't like inheritance. And also I read in Effective Java by blog that inheritance is evil. So this pattern allows you to use composition. You just composite execution strategy in the context, which is job runner. And you don't have all this pain that inheritance can bring at the end. And yeah, open close principle, like the implementation of strategy basically closed, but method to use it is open, I would say like this. Yeah, and you don't need to change the context. That's also important. And the problems that you can just don't know that there are already strategies that you need. You just do not understand by the name of the class. So the other developer comes and bring one more strategy, the other developers create 3 more strategies, and there are hell of strategies. Okay, that could happen. A lot of modern programming languages has functional type support. Yep. So you can use lambdas, you can program in Scala without strategy because you just create new functions. Also, even with strategy, that can become just functional interface because we have only one method basically. And well, I wouldn't say that actually withdraw, like this is the flow of the pattern. But yeah, if you programming in functional language, probably you don't need this strategy because you just use your lambdas. Yeah, if you have something in mind, probably you already meet somewhere in the code base or some like 20 seconds if you have example. Yep. Anyone wants to say anything?
Comparator also can be seen as a strategy.
Exactly. Thank you. Yes, that's true. That's basically the strategy to compare elements in collections in Java. Yeah, that's true. Okay, so yeah, we have also channel on object-oriented programming track in our Slack. So let's share examples there as well after this session. And next pattern, chain of responsibility. Well, I would say that I used it in my experience, in my practice. It's allowed me to simplify code a lot. And I will show you example. It's very close to the things that I did in my experience. So yeah, that's interesting pattern. And let's look at it. So problem statement, vehicle service, and it accepts vehicle offer. You can think about it as a platform that accepts different offers to sell them. Basically, it's like eBay, but for vehicles, for example. Probably you know your favorite service to sell and buy cars, or probably use eBay. Probably it's possible to do it through eBay or Gumtree. I don't know exactly, but that's the statement. Like, you need to analyze this offer. You need to think about, like, you have a lot of offers. They have the same structure, and you need to save. Some of them you need to save in car service, some of them you need to remove, some of them you need to save in truck service, which responsible for truck, which will render them for trucks, and the same for motor services. Oh my God, I think I changed them a little bit. So this was like the first thing to save them. And when more requirements came, and you have this help of different conditions, like if it's car and if it's BMW, we save it, like was probably the first requirement. If it's truck and BMW, we save it. If it's motor and it's black, we save them. But now we have more conditions. And if it's car and it's already created, this offer created 10 years ago, then we delete them. If we have track and basically creation date of this offer, for example, 5 years ago, then we remove it. And for motor, for example, 3 years ago. Or you can play with your numbers as you want. So how we can apply here pattern chain of responsibility? Please follow me. So it's very interesting. I want to create filter, and I want also have next filter. Let's think that the order is super important for us. So I know what is the filter. The first one to look at cars, for example, and the next one to look at trucks. And I create this filter as an interface, or even here I created it as an abstract class because I want to say, like, you know, this filter, it always has next filter, or probably it's now. And my filter function will check if I have next filter, and it will return next filter, and basically that's it. Yeah, and also we also have to apply our conditions. What exactly our next filter? Now I implement these filters. So I create car BMW filter, and I say my filter function is filtering. Yeah, okay, that's right. Everything is right. So if my data applied, I return them. If not, I return filter from the superclass. And superclass do not do anything, but just check. If I had filter, if I have next filter, I will provide it to next filter. That's it. I believe it's beautiful. Like, yeah, you just provide the logic for your filter, and you otherwise you ask the filter that is super class. Or you could create here method filter next, which will have the same implementation. And you say instead of super filter, filter next, which will be already here in your class because you implement abstract class. Yeah, and I promise that we will repeat solid principles and creational patterns. So here is creational pattern, which is Singleton. You saw another example with thread safe example, which Avivsha gave. Here is an example how to create a singleton with static method and private constructor. Actually, I found this example in Effective Java by Georgia Bloch, and yeah, you just create private constructor, which means that no one can access this constructor. And to provide the instance, you can go even further and create the field, which will be public static field, and you create your constructor. Because it's private, no one else can access it. And because it's static, it will be created on the stage when the static metadata for this class will be created. That means only Java machine will create this class for you. So it will be automatically singleton. No one else in the system will be able to create this class. So this is how to create singleton by like several lines, and you can guarantee that no one else can create this class. It will be only one instance through the whole your system. Yeah, and in this filter, because I need only one filter in my system, I don't need another classes, and I want to avoid it. That's why it's singleton. And here I have filter function. As I already said, I have implementation of basically what I mean by filter, and I postpone it to next filter. And how I now I have vehicle service, and my service is for cars, trucks, and motor. And I also create only one filter to save or filter to delete. And filter to save, basically, I said there are next filter. First of all, I say that filter car BMW, then set next filter for truck BMW, and set next filter for motor black, and that's it. And also filters to delete outdated cars, outdated trucks, and motor outdated. Yeah, and that's it. Now that's how looks my vehicle service after my refactoring. I also did some trick here. I said like, okay, I already know that I know marks of the data. in perfect code, it will be, of course, enums. I just simplified, that's why it's strings. And yeah, I just say like, I would filter data, and if filter applied, I save it. Which service? Well, it depends on the mark. I just get mark and save it in the service. And the same about deletion. But now instead of trillion if conditions, I just have this beautiful logic with filters and services. Okay, class diagram. So what we are doing in chain responsibility pattern. Basically, my filters are handlers. And I have handler as an interface or abstract class. As I said, in my case, I use it abstract class. And I implement it by concrete handler 1, which is car filter, and concrete handler 2, which is truck filter. And my client, it's my vehicle service. Yeah, and also these handlers, they have references to each other. And if I create this diagram for the code I showed you, this will look like this. We have vehicle service, we have filter, and we have different implementation, which applied one by one. Okay, who can tell me where it will be even more efficiency? If you have any idea, like what else you can use to, where you also will use this chain of responsibility pattern. I would say that it's very powerful when you really need strictly to apply different changes. For example, you have authorization for user. If you will Google for it, you will find exactly these examples. So I just wanted to create something new, something more interesting. But basically examples, you have user, you have authorization, and to go through 2 steps to verify user, they need to do a lot of steps. And all the steps can be part of the long chain. And if one of the conditions haven't been applied, you drop the whole chain immediately, and you can allow user, accept user in your system only if your user went through all these steps. Chain of responsibility. So advantage is that you basically control the order. You can strictly say that this is the first step, this is the second step, this is the first step. Single responsibility, decouple classes and classes that perform operations and classes that invoke operations. Open closed principle. You can introduce new handlers and you don't need to change anything in your app. You just put a new filter, new handler as a next handler of the previous handler, and this is the only changes in your system. And yeah, I believe it's very powerful, and it has disadvantages as well. For example, some objects may end up unhandled, like they dropped at the first filter, but basically they couldn't be dropped if they need another filter in another place. It's difficult to change it. And sometimes you need to go through handler twice if it's possible. Like sometimes you need it. And with this pattern, you can't go twice through the same step. You need to put it as, you need to create always a new filter if you need to go twice through the step. So it has some withdrawals, but it's very powerful. And the last for today, and this is Iterator. And I think it's pretty simple for people who are familiar with Java, because we have implementation of this pattern exactly in our Java util library. And almost everyone at least once heard about it if you worked with Java, like Iterator. It's basically to iterate through the collection, and this iterator has next method. It's allow you to know if you have something next in the collection. And then if you aware that there's something next, you can go and get this next element and remove this element. Now, to provide some example of implementation of this pattern, suppose we want to iterate only through uneven elements. How would you solve it?
It's a kind of a strategy. Maybe we have suppose that we have iterate implementation, and based on your explanation, it's some extra behavior which we would like to add. So I would say that we need a context, and we will have some in that context some kind of execution. Yeah.
Okay, that looks interesting. And as I said, as only you're aware about strategy pattern, you would like to use it everywhere. Believe me, that's true. And yeah, it's the first idea to use strategy. This always happens with people who learn strategies. They want to apply them, it's everywhere. Okay, well, not exactly. We need to implement the same behavior of the iterator. So basically the pattern will be the same, but we need to go just next, and we need to check if it has next. But the thing that changed, that we need to go 2 steps instead of 1 steps. And let's start with TDD. Well, I love this task because I even was asked it an interview. At interviews, they asked me how to implement an even iterator. And let's check how we would like to do it. What exactly is the behavior that we are going to see at the end. And we say that, okay, we have this uneven iterator, and when we get next method, we wait that we will go at the position 1. If you will use just regular Java iterator, you will be on the position 0. So 0, 1, 2, 3, 4, 5, 6, that's something that Java iterator will give you. But here we want to be at the next position at first at 1, and the next at 3, and the next at 5. That's what we expected. And we write tests like, this is what we expected. Should return an uneven element. And also we want to remove element, and that also should be an uneven element. So I put the comments here. So if you remove, we expect that you removed not the first element, but the second. So you removed 1. 1 removed, and iterator becoming at the previous step. So it's at the element 1. And now if we want to go next, we do again 2 steps. So we becoming at the uneven index, which is 3, but the element is 2. And yeah, if we remove again, we remove exactly 4, because again, we do 2 steps because we want every time be on uneven index. And we remove 4, and in this case, iterator at element 3. I will send you a presentation, so you will be able to go through it again. And let's look at implementation. So, uneven iterator. We can use iterators there, but we will do some tricks. Your ideas, how we can do it by 2 steps every time. Well, the trick is simple. We just do 2 steps. We check if elements which already iterator has next, and just do step, but do not return element. If there are no element, we throw no such element exception, because this is basically what we are going to throw. And then we check again. So we have 2 steps. And that's it. We just do 2 steps, but return on the second step. In this case, we have uneven iterator, so we can be sure that we always go through uneven elements. Now we implement it next. How we would implement remove? Any pit fails for remove? What do you think?
Can we remove the first element from this?
But in this case, we will remove just the same as iterator remove. Well, actually, there are no pit files, and it can be the same that next method. We just check if there are next element, get this element, but do not remove it. We just go again, and again we check if there has next element, and then only then we remove it. So we just do extra step at the first element. And that's it. And it will work. I checked my test. My tests were green. Yeah, so how it looks like for diagram. So you have iterator interface, iterator first implementation, second implementation, and both of them has next and has next. If you check all these iterators that Java collection have, they have implementation as inner classes. And you put them in some collection, basically. Yeah, so if we would like to look at how we would use them, we always have clients that have iterator and aggregate, which create iterator. Yeah, if you check libraries in Java, like array list, linked list, you will see how this pattern by these diagrams implemented there. So yeah, and I put it here. So in Java, you have abstract collection. This is aggregator, and it has iterator inside as composition. Yeah, so what we can see here is the same. And yeah, so basically in this abstract collection, we create iterator. Yeah, and I put the example here. So this is Java released, and this is what we can see for implementation of iterator pattern. So basically, Java released has array under the hood. So iterator go through this array of objects. So if you look at the line here with object, with array, you will see that this is basically the collection that we are going to iterate through. And it's trying to do here just for cycle, but return next element by the next index. And it has indexes like the cursor inside. So this is how Iterator implemented in Java. So what is advantages? You can use Iterator if you implement some map interface and you would like to provide the next step for your traveler. So traveler just need to get next method, and that's it. Yeah, you can imagine you have traveler, and it looks at map, and it only check if it has next location to travel there, or it already went through all locations, so can go and sleep. And if it has next location, it just go to next location. That's it. So you can support multiple traversals of aggregate objects. Aggregate objects is your collection. Multiple traversals means that iterator and uneven iterator. This advantage, you can have also uneven iterators. And the idea of this pattern to provide uniform interface for traversing for different aggregate structures. And that's basically what they did. And that's basically what Java used. Java used this uniform interface. And disadvantages. Applying this pattern can overkill your app because, yeah, if you have just simple collection, maybe you need just iterator that already implemented. And also collections by default, they have some optimizations. So probably it's always better to get already implemented iterator from collections that's already implemented, and do not implement this pattern by yourself. Yeah, okay, so, well, on these sessions we covered already Singleton, abstract factory, facade, prototype factory method, Singleton, yeah, builder. And today we covered strategy, we covered chain of responsibility, we covered state, and we covered iterator. And I hope you liked it. This is sources. This is tutorials point my favorite in this list. They have very related to real life examples. Group patterns, very beautiful examples as well. Golf patterns, well, you don't need to buy original book. They have the same thing on the side. And yeah, you also can refer to Head First Design Patterns in Java, which is ebook. It can be found for free. And you just need to try to find. And they also have very good explanations on design patterns in Java and for design patterns in object-oriented programming. Okay, do you have any questions? Okay, I start my presentation. Wow, thank you for surviving, for people who left here. Oh my God, there was a lot of comments. Oh, I'm sorry, I wasn't able to read them. And I stopped recording.